Hello students and welcome to my channel Maths Hub. So today in this video, we will start the playlist for matrices. So in this video, I'll give you an introduction to matrices that you already know in your junior classes, right? So but we will do a recap what all matrices is all about, and then we will move on to the complexities of matrices, right? So to begin with, what is a matrix? By a matrix, what do we know? That it is just a representation of something in terms of rows and columns, right? So how do we represent a matrix? It's a rectangular arrangement of number of functions which are represented as. So you can see here that if we are taking numbers, we are representing the numbers as A11, A12. So we are putting the numbers or functions in terms of rows. So the horizontal lines, they are representing the rows, and the vertical lines, they are representing the columns, right? So it's an arrangement of putting the numbers in terms of rows and columns. So here you can see that there are m rows and there are n columns, right? So there are m rows and there are n columns. So this leads to a total number of arrangement of m into n elements, right? So when we write here m cross n, m depicts the number of rows and n depicts the number of columns, right? So any matrix is enclosed. When you put the numbers, we enclose them in the form of a round bracket or in the form of a square bracket, right? And the general element of a matrix is represented as Aij. So when we say that a matrix A is equal to Aij, so what does I and J represent? I represents the row number and J represents the column number, right? So for example, if I have to represent this element, sorry, I have a very bad throat. So you can see that A22, it is lying in the second row and in the second column, right? So the first two is representing the row number, the second two is representing the column number. Similarly, if I choose this element, it is showing AM1. So AM1 means M is the row number, so it is present in the mth row, and 1 is the column number, right? So you can represent any element of the matrix by the symbol Aij, where I and J are the corresponding row and the column number, right? Okay, so let's move ahead and let us see what are the types of matrices. So the first type of matrices is a row matrix. So what is a row matrix? In which we are representing the elements in the form of one row. There can be any number of columns. So you can see that all the elements are represented in one row since one row is present. So this type of matrices is called a row matrix, right? Now the second type of matrix. It is a column matrix. So when we put the arrangement in the form of columns, so here you can see that there is one column there and there can be any number of rows. So when there is one column in the matrix, it is called as a column matrix. Then let's come to the third one. The third one is a square matrix. So what is a square matrix? A square matrix is when your row number and your column number is same. That means whenever m is equal to n, so here in this case m is 2 and n is 2. So the row number, there are two rows, there are two columns. So when the row number and the column numbers become equal, then that type of matrices is called a square matrix, right? So it can be any number. There can be 3 rows, 3 columns. There can be 4 rows, 4 columns. So you should have to take care that the row number and the column number must be equal, right? Then the next type of matrix is a rectangular matrix. So when the arrangement is not same, that means the row number and the column number is not same, it leads to the shape of a rectangle. So here you can see there are 2 rows and 3 columns. So the number of rows and the number of columns are unequal to each other, and hence it will be defined as a rectangular matrix. So it's very simple. If a matrix is not square, it has to be a rectangular matrix, right? So you can also say that a row matrix and column matrix are also types of rectangular matrix, right? Okay. So let's move on to the next type of matrix. So the next type of matrix is a diagonal matrix. So what happens in case of a diagonal matrix? In the diagonal matrix, you will see that only on the diagonals there are certain elements. Rest all the non-diagonal elements are zero. So a diagonal matrix is always a square matrix in which the non-diagonal elements are zero. It can happen that some of the diagonal elements are also zero, but it is mandatory that all the non-diagonal elements need to become zero, right? So that type of matrix is called a diagonal matrix. Then the next type is a scalar matrix. A scalar matrix, it's a square diagonal matrix in which all the diagonal elements are equal. So it has to be a diagonal matrix first of all. So when we say that it's a diagonal matrix, that means all the non-diagonal positions are zero. And on the diagonals, all the elements must be same. So it's not necessary that it has to be 5. It can be 1, it can be 2, it can be 3. So whatever number is there on diagonals, all the numbers must be same. Then that matrix is said to be a scalar matrix, right? Then the next type of matrix, it is a unit matrix. So whenever a scalar matrix in which the diagonal positions become 1, it becomes a unit matrix. It is also sometimes called as the identity matrix. So you must be familiar with this name instead of unit matrix. So unit matrix is also known as a identity matrix. So you can see that this is an identity of order 3. There are 3 rows and 3 columns, right? So whenever we talk about a diagonal matrix, it is always a square matrix, right? So a diagonal matrix, a scalar matrix, a unit matrix, they are all square matrices. Okay. So the next type of matrix is a upper triangular matrix. So what happens in upper triangular matrix? It is again a square matrix in which all the elements below that principal diagonal, they all become zero. So what is the principal diagonal? So when we have a square matrix, so all the positions where the row number and the column number become same. So if you check where the row number and the column number are same, here the position is A11, this is A22, this is A33. So you can see that the row number and the column numbers are same only in these 3 positions. So this is your principal diagonal. So mark the principal diagonal. All the elements below the principal diagonal, they should become 0. Then we say that the given matrix is a upper triangular matrix. Similarly, if on marking the principal diagonal, all the elements above the principal diagonal become 0, then it becomes a lower triangular matrix, right? So that is what is there in the next type of matrix. So a lower triangular, you can clearly see that if I mark the principal diagonal, this is my principal diagonal, and you can see that all the elements above the principal diagonal, they are termed as 0, and hence it is a lower triangular matrix, right? So the naming is opposite to what is happening here. Okay. So the next one is the transpose of a matrix. So transpose means when you interchange the rows with the columns and the columns with the rows. So for example, if you have the matrix A as 1, 3, 5, 3, 7, 9, this is a 2 cross 3 matrix. So when you take its transpose, the row number will become the column number and the column number will become the row number. So the new matrix A transpose, it is written by the symbol AT, or you write it like A with a dash, right? So here, this matrix, what will be the order? It will become 3 cross 2. So the first row will become the first column, the second row will become the second column, right? So you need to interchange the rows with the columns, and when you interchange the rows with the columns automatically get changed with the rows, right? So that is what is a transpose of a matrix, right? Okay. So the next type of matrix is a symmetric matrix. So what is a symmetric matrix? It is again a square matrix in which the transpose of the matrix and the given matrix are same to each other, right? They're equal to each other. Then the matrix is said to be symmetric. So for any matrix to be symmetric, it must satisfy this condition that the matrix and its transpose must be equal. So let us check this matrix A. A is 1, 3, 5, 3, 4, 1, 5, 1, 9. So let us take its transpose. So when we take its transpose, the first row will become the first column. So we get 1, 3, 5. The second row, 3, 4, 1 will become the second column. The third row will become the third column, right? So now just check the two matrices. Are we getting that A and A transpose are same? Yes. So that is why this matrix is a symmetric matrix, right? So the next type of matrix is a skew-symmetric matrix. So what is the difference in a skew-symmetric matrix? In this, A should be equal to minus of A transpose, right? So whenever for a square matrix A, if A is equal to minus of A transpose, then it is called a skew-symmetric matrix. So let us check this matrix. In this matrix, we need to check that A and A transpose. A should be equal to minus A transpose. So let us calculate A transpose. So the first row 0, 5, 7 will become the first column. The second row minus 5, 0, 3 will become the second column. And the third row, that is minus 7, minus 3 and 0, that will become the third column. So now if I take out negative sign common from here, what do I get the elements as? 0, 5, 7, minus 5, 0, 3, minus 7, minus 3 and 0. So is this matrix same as matrix A? So I'm getting what? A transpose is equal to minus A, right? And another interesting fact that whenever we have a skew-symmetric matrix, the diagonal elements are always 0, right? So that also helps you to recognize whether it's a skew-symmetric matrix or not, right? And you can see that the elements that are above the diagonal and below the diagonal, they are almost similar with a negative sign, right? So that is the identification that whether the given matrix is a skew-symmetric, right? So I hope the introduction to matrices is recalled, right? And we are in a position to understand what is a matrix. So in the next video, I'll tell you about the elementary transformation. So thank you so much for listening to me. If you like the video, do hit the like button. And those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. And believe in yourself and you will be definitely succeeding. Thank you so much.